Okay, so if you go to GitHub and you go to this here, so it's on your mark NEU, and then UI Data Science, or UI Data SC. And if we check that, so this is a program that we're going to work on, plus some data files here. So I wanted to show you what the program looks like, and I'm not sure I'll be able to get it running on my computer in class because I may not have it set up properly, so I'll show you here. So the main file is called main.py, and it starts out with the typical import statements, and let's just see how many lines it is. Okay, it's about 300 lines, and let me just try and run it, and I'll run it from here without debugging. Let's see if it works. Taking a little time, but finally it shows up. So this is the program, and basically I want us to work on this together. So we have a couple different tabs up here. So there's one called pre-process, and then there's another one called classify, and then there's another one called visualize. And so the idea is that actually underneath the hood, we have Python code here, and we can add in different features to this program using Python. So let's just see what we have so far. So the first thing is that we want something that will open up a file. So here's a button, and if we click it, we get this, and we can open up a file. So let's try opening up the first one, the weather one that we're familiar with. So I'll click open. And then what we see over here are the so-called variables or attributes, and we recognize the outlook, the temperature, the humidity, windy, and play. And then when we click on these, it's going to generate a graph. So we have to write the code that will generate graphs like that. Well, it's already done for this, but you can see. So here we can see that the orange is yes, and blue is no, and that's for the play variable. And we have overcast, rainy, and sunny. So maybe we need to do some work on this because it's not so, you can't really see that completely. But anyway, for example, overcast we can see is all orange, so that means they always play. And then up here we have another little window here, and we have some statistics about this particular variable, about the outlook variable. So for example, we have the count, the number of rows. We have how many different unique values there are, and we see that there's 3 down here. We have the top is sunny. I guess that means the most frequently occurring one is sunny, and the frequency for that is 5 perhaps. And the name of this variable is outlook. Okay, we can try it with this. And again, the color overlay is going to be the same. It's going to be the last variable here. But now we have the variable is temperature, and we have 3 different values, or as I call them in class, levels. Humidity, 2 different possible values, windy, and play. Okay, so that's that, the pre-process tab, and we might want to add additional features to this. But anyway, let's go to the classify tab. So in the classify tab, we have this display, and we can select different algorithms. So right now we have 3 algorithms, but we'll definitely want to add more to this list. And I'm not even sure all of these, I would be very surprised if linear regression works on this data set. I'm not quite sure what will happen if we try it, but let's try it. So suppose we try linear regression on the weather data set. It shouldn't work because it's the weather data is not numeric, and regression is for numeric data, so nothing happens. Okay, now that's not maybe the best response. Maybe there should be some indication that it's not going to run instead of letting the user run it and nothing happens. Okay, the next one is called logistic regression. That probably won't work either, but let's just see what happens if we run it. Nothing. But the last one is called, this is kind of like our 1R, kind of more complex version of our 1R. And let's try and run that. And that doesn't run either, okay. So none of these work. And the Visualize tab, there's nothing there. It doesn't work, rather, I don't think. No. Okay, now let's try opening up a different data set. So let's try this one. So this one is about rice and fertilizer. So we want to know, does fertilizer improve rice output? So we might want to make predictions about that. Anyway, let's open this up. It only has 2 variables, not 5, like the like the weather data set had. So let's open it up. Okay, we only have 2 variables, fertilizer and the yield, which means the amount of rice that is yielded in a field of rice. And this is wrong. Oh, sorry. So this hasn't changed yet, but once we click on here, it changes. Okay, but we don't have a color overlay here, but that's normal because typically, because yield is a numeric, and typically we wouldn't have a color overlay in that case, but we could. And then we can also, so this is the graph of fertilizer. We can see that it, for example, fertilizer, the data apparently extends from 25 to 200. So that's the range of the values for this variable. And we get something like the count. So the count is the number of rows in the data set, and the mean for the fertilizer, I guess, is somewhere around 95, and the standard deviation, the minimum, and the 25th percentile, 50th percentile, and so on, and the maximum. Okay, so then we can also click on the yield and see what that looks like. And so that goes from a number like this, which is about 100,000, to a number like that, which is about 220,000. So apparently that's what the yield variable, those are the typical values in the yield variable. So we can, anyway, this graph is generated. And let's see if we can run any of these algorithms for this data set. So let's try it. Now this one should work because this kind of algorithm is meant for this kind of numeric data. So let's see what happens if we run it. Okay, so it does work. It doesn't give us a lot, but it does work. And basically what it gives us is an equation. You can recognize this as an equation. It's y equals a constant plus a variable times another constant. So that's like y equals, this part would be mx plus b. So that's definitely the equation of a line. And so that is a model for this data. Okay, and I don't expect that this will work, because we haven't talked about this algorithm, but it shouldn't work for this data. Oh, but it does, and I'm not quite sure what it's doing there. So let's not worry about that. This is kind of meaningless, and maybe we want to avoid running it on this kind of data. But anyway, let's go back and try one more type of data. Let's see, we'll open up this. And here we have the iris data, or actually we have 2 versions of the iris. Let's try the one that we're familiar with. So that's this one. And here we have sepal length, sepal width, petal width length, and petal width in the class. Now this, we would like to have the class show up as an overlay here, but it's not working. So we might want to fix that somehow. We could call that a bug, and we want to fix it. So it doesn't show up here, it doesn't show up here, it doesn't show up here, it doesn't show up here. Okay, but we do get the distribution of these different variables here. We get the distribution of this variable and so on. They look different, of course, and their minimums and maximums and count. Well, the count will be the same, but the minimums and maximums will probably be different depending on which variable we click on. So this is 3 up to 4.4, and this is different, 3 up to 6, and so on. And we can try this. And now in this case, actually this should work. Logistic regression is called. Should work, it does, and it does make sense. I'm not sure if this particular output makes sense. Now look over here, by the way, you can see that there's supposed to be more showing here, and it's not, so we need to fix this at some point. Let's see if J48 works with that. By the way, this J48 should have worked with the weather data, and maybe it worked here. Didn't seem to change, but let's see, J48 versus logistic. This is 1, 1, 1, 1. Let's try it, just try. Yeah, I'm not sure if it's working actually. Okay, and one more. Let's try this and open up one last piece of data set. And this is the iris one, but it's only got one input in it. So let's try it. So we only have petal length. So we're only using petal length to predict the class of the iris. So here we get the color. I don't think we got it. I don't think we got it. Well, maybe we did. Let's check that first. Let's go back to here and see if we get the color. Let's see. We do get color for this, but it's not showing up on the as an overlay. Okay, but let's go back to here and here and here. And okay, so now we have a much more limited version of the iris data set because we only have one variable here, but can just check to see if any of these work. Now, logistic regression might work, but it doesn't seem to be changing. I'm not sure it's actually working. And linear regression should not work, and that doesn't change either. So, okay, so there's some problems with this, but that's the point of this project, or one of the points. One is we want to add in new features, but we might want to work on figuring out why it's not showing up as we want it to. Okay, so let's close this. So as I said, this is the main file for this, but you may have noticed that there was another file called J48. So if we want to add in a new algorithm, we can write the algorithm, and then if we name it properly, we can run it. So going back to here, you can see here's the main. This is, you can ignore this one. We have the weather data set there, we have the J48, and so on. Now here's a little tutorial or a high-level walkthrough of the code. So let's just open that up. So if you click on that, and you click here and you download it, you can open it, and we can take a look at this. So this is written in Python, as you can see here, but it's using a module called tkinter. That may not be the right way to pronounce it. So here you can see it. Maybe it's tkinter, I'm not really sure. But tkinter or tkinter is the name of a module that is, I believe it comes with, we don't have to, well, maybe we do have to import it, but we can import it, and we can build GUI interfaces using Python with tkinter. Of course, they're not the most sophisticated looking interfaces, but we can build them nonetheless. So let's just read a little bit of this. tkinter is the standard graphical user interface GUI library for Python. It provides tools to create interactive GUIs in a relatively straightforward manner. The name tkinter is derived from TK interface, where TK is a GUI toolkit. So obviously there's a window here, or we call this a window. And the window, or the root creation, the main window is where all your widgets like buttons and labels and so on will reside. It's created using this code, TK, dot capital T K with so this is the constructor for that. And then we can add in interactive elements called widgets. So we can add in labels, and you can see that we have labels and we have buttons and we have these panels here, and we even have tabs up here. So you can add in labels, buttons, a single line text box, a multi-line text box, list box, check buttons, radio buttons, and many more. And then there are what are called layout managers. Says once you have the widgets, you need to specify how they should be arranged in the window. This is done using the layout managers. And the primary ones are pack, grid, and place. So as far as I recall, we're using just this one, pack, but we could use grid or place. So this pack packs widgets in order, either at the top, bottom, left, or right. Grid places them in a grid layout, and place places a widget at a specific position that you can provide. And we need some so-called event handling for the buttons and clicking and so on. So we have to incorporate that. Okay, and then there's a main loop. And here's a quick example. So here we would import tkinter as tk, and then we could define something called an on-button click method. And what this is supposed to do is we're going to create a GUI window with a label and an entry box to take a user's input, their name, and a button. And when the button is clicked, the label is updated and to greet the user with their name. So it's going to show up as a label, and that label will be changed when the user clicks the button and enters their name. Okay, so why should we use tkinter? It's bundled with Python. It works on Windows, Mac, and Linux, and it's very simple. Of course, there are limitations. For example, the way this looks is not so appealing, but we can use it. And the complexity, it's not, we can't do too many complex programs. Okay, and this is an overview of that application that we just looked at, this one here. So we have the pre-processing tab, we have the algorithms classify tab, and we have a visualizing tab, which hasn't been implemented yet. In the pre-processing tab, we can load a CSV file, we display available variables, and we can view basic statistics and graphs for a selected variable. And then on the next tab is the classify tab, and we can apply machine learning algorithms there. And maybe we'll have more flexibility, more options in there. And then we have a visualizing tab, which again, that hasn't been really implemented yet. Okay, so you can go through and read some of this, and this should help us understand the code in the Python file.